Welcome to the Deep Dive. We're taking a deep dive into something pretty mind-boggling today, the concept of a fractal universe. Now, you might be thinking, fractals, or are we talking about those trippy images you see in math class? But get this, what if this mathematical concept, fractals, actually helps us understand how the entire cosmos is structured? Pretty wild, right? Hit that like button and subscribe if you want to follow us down this rabbit hole.
It really does change how we think about the universe, what we're talking about. Imagine like a universe where the same patterns just keep repeating. And these same structures show up, but at completely different scales. That's basically what a fractal universe is all about.
Okay, so let's break this down a bit. For those who need a quick reminder, think about a snowflake. They're intricate and beautiful, right? But the thing that makes them really unique is that they're self-similar. So you can zoom in on any part of the snowflake, and what do you see? The same pattern repeating, but smaller.
Exactly. And that's the whole idea behind fractals, these really intricate patterns repeating at different scales. Think about coastlines. The closer you look, you see more and more and more detail. And it's the same with trees. The branches kind of mirror the way the whole tree is structured.
Okay, so are we saying that galaxies might actually look like atoms if you zoom in close enough? And the way stars are clustered could, echo how planets are arranged in a solar system?
You got it. It's a pretty crazy concept. It suggests that maybe there's a much deeper order to things, like some kind of fundamental order, even though the universe might seem random. But hold on tight, because to really explore this idea, we need to go beyond, the normal numbers and into some pretty complex math.
Complex math. Oh, boy. That sounds a little intimidating, but I'm sure you can guide us through it.
Don't worry, I'll keep it simple enough for anyone to understand. The key person here is Benoit Mandelbrot, a mathematician who basically invented fractals. He was convinced that we see fractal geometry all over in nature. It kind of challenges the way we normally think about things, with smooth lines and perfect shapes.
So instead of thinking about the universe like it's full of all these neatly defined objects, we should be thinking about, jagged edges, infinite details, and patterns within patterns.
You got it. It's like a whole different way of seeing things. We learned Euclidean geometry in school, right?
Yeah.
But this is like saying, actually, irregularity and complexity, those are like the basic building blocks of the universe. It's like realizing that the world is built with Legos. And we can keep zooming in and finding smaller and smaller Legos, and they're all part of the bigger picture.
Okay, I can feel my brain stretching already. But there's a big question here. Is there any real evidence that the universe is actually a fractal? Or is this just, a cool mathematical idea?
That's where things get really interesting. There's no definitive proof yet. But scientists are looking at some pretty fascinating observations that make them wonder. Did you know that the way galaxies are spread out across the universe isn't random? They kind of cluster together in these patterns. And you know what? Those patterns actually resemble what we see in fractals.
So we're seeing these hints of fractal patterns, but at a cosmic scale. That's pretty wild. But I'm guessing there's a lot of debate about this in the scientific community, right?
Absolutely. Some scientists are, they're pretty cautious about saying these patterns are definitive proof of a fractal universe. It's kind of like if you found a few puzzle pieces that seem to fit together, and then you try to picture what the whole puzzle looks like. We need more data, more observations, to really connect all the dots.
Yeah, I could see how that would be tricky. We're talking about scales that are so vast.
Yeah.
It's almost impossible to really grasp it all. But let's say, just for a minute, that the universe is a fractal. What would that mean for how we understand how everything works?
Now that's where things get really mind-blowing. A fractal universe would suggest that the universe is complex on a level that's almost impossible to understand. It might even mean that what we think of as the entire universe is actually just a tiny piece of a much, much larger structure, a structure that extends infinitely in every direction.
Infinitely in every direction. Whoa. Wait, so you're saying there could be whole other universes tucked away inside our own, and our universe could be inside an even bigger one. It's like those Russian nesting dolls, but on a cosmic scale.
You're getting it. It challenges everything we think we know about size, scale, even what's real. But before we, get too lost in this infinite rabbit hole, let's zoom in a bit. Let's explore some of the mechanisms that might be at play in a fractal universe. One really important concept here is chaos theory.
Chaos theory. I feel like I've heard that a lot, usually in those movies where they're trying to predict the weather. What's the connection to fractals?
Chaos theory is all about systems that look random and unpredictable on the surface. But underneath, they're actually following hidden patterns and rules. Have you ever seen a double pendulum? It swings in these weird, unpredictable ways, but it's all within a certain space. And you know what? That space is governed by mathematical rules. And when you visualize it, guess what you get? A fractal pattern.
So even in chaos, there's a hidden order. And that order could be expressed through fractals. That's pretty deep.
But how does this connect to the universe as a whole? I mean, it's not like there's some giant pendulum swinging the cosmos around.
That's where it gets even more interesting. Chaos theory tells us that the universe, especially when it was just starting out, was incredibly sensitive to even the tiniest differences in the starting conditions. Think of it like, a butterfly flapping its wings in Brazil. And that causes a tornado in Texas. It's called the butterfly effect. It's a classic sign of chaotic systems. What it means is that even the smallest changes can have massive consequences over time. So you're saying that everything we see in the universe today, the galaxies, the stars, even planets like ours, could have all been shaped by tiny random things that happened way back at the beginning of the universe. It's like rolling the dice at the start of time and then letting the game play out for billions of years.
That's the idea. And this sensitivity to initial conditions, that's a key feature of chaotic systems. And they often end up showing these incredibly complex and beautiful fractal structures.
Okay, now I'm starting to see the connection between chaos and fractals. But this is all feeling a little abstract. Can you give us an example of how this might work in the universe, like something concrete?
Okay, picture the early universe. It's like the swirling soup of energy and matter, right? Now imagine tiny random fluctuations in this soup, like little ripples on a pond. Those could have acted as seeds for galaxies to start forming. Over billions of years, gravity would have pulled matter together, making those initial fluctuations bigger and bigger, until you get the huge cosmic structures we see today.
So the universe starts with a tiny bit of chaos. And that chaos, following the laws of physics, eventually creates all this incredible order and complexity.
Exactly. And those fractal patterns we see in how galaxies are arranged, those could be like echoes of that original chaotic state. A reminder that even the biggest structures in the cosmos started from something random.
This is seriously mind-blowing stuff, questioning everything I thought I knew about the universe.
Yeah.
But before we go any further, I think we need a minute to let this all sink in.
I agree. It's a lot to take in, but trust me, it gets even wilder from here.
We'll be right back in part 2 to explore even more of this amazing fractal universe. Don't go anywhere.
Welcome back to our deep dive into the fractal universe. Before we kind of went off on a tangent there, we were talking about chaos theory and how it could help us understand like how the universe is structured. It seems random, but also has a strange order to it.
Yeah, that's right. The idea was that even tiny changes at the very beginning of the universe could have ended up creating the galaxies and stars we see today. It's almost like the universe rolled the dice at the start, and everything that came after was because of those initial conditions. But how do we even begin to, visualize this chaos?
Okay, so that's where the idea of phase space comes in. Imagine, instead of a normal map with, cities and roads, you have a map of all the different states a system could be in. Each point on this map represents a different configuration of the system. It's like a snapshot of its energy, position, momentum, all of that.
So instead of places, this map shows all the different ways the universe could be arranged.
Yeah, exactly, like a cosmic blueprint of all the possibilities. And as the system changes, the point on the map moves, tracing a path. We call it a trajectory through this phase space.
So it's like tracking the journey of the universe through all its potential states. But how does this help us understand chaos?
Here's where it gets super interesting. In systems that are chaotic, these trajectories often end up converging towards specific areas within the phase space. We call these areas attractors. Imagine a marble rolling around in a bowl. Doesn't matter where it starts, it always ends up at the bottom, right? That bottom point is the attractor.
Okay, so the attractor is the most stable state for the system, but
Yeah.
how does that tie back to fractals?
Well, in chaotic systems, these attractors can be super complex, and they often have these beautiful shapes that are self-similar, just like the fractals we talked about earlier. Instead of being simple points or loops, they can be these strange multidimensional structures that twist and turn in these mind-boggling ways. They're called strange attractors, and they're key to understanding the order that hides within chaos.
Strange attractors. It sounds like something straight out of science fiction.
It kind of is. They're like the fingerprints of chaos, you know? They reveal the underlying patterns in behavior that seems random. One really famous example is the Lorentz attractor. It was discovered by a meteorologist who was studying weather patterns.
So even something as unpredictable as the weather could have a hidden fractal pattern.
Exactly. When you visualize the Lorentz attractor, it looks like a butterfly with two wings. The system's path never repeats, but it's always drawn towards this butterfly shape.
It's almost poetic, finding these beautiful, complex structures within something as chaotic as the weather. But we're talking about the universe, something infinitely more complex. How do scientists even begin to analyze something like that?
It's definitely a challenge, but there are tools and techniques that can help us break down this complexity. One of them is called the Poincaré section. It's a way to simplify how we visualize chaotic systems. Imagine slicing through that strange attractor in phase space with a plane. The points where the system's trajectory intersects this plane create the Poincaré section.
So it's like taking a 2D picture of a 3D object, a way to see the essence of the attractor without being overwhelmed by its complexity.
You got it. It's a way of reducing the dimensions without losing sight of how the system behaves.
All this talk about dimensions makes me wonder, if the universe really is a fractal, does it even have a set number of dimensions? Like, we usually think of 3 dimensions, length, width, and height. But fractals can have fractional dimensions, right?
That's a great point. And it leads us to one of the most mind-bending aspects of a fractal universe. Our whole idea of dimensions might need to change. Remember the coastline example. The more you zoom in, the more detail you see, and the length you measure increases. It suggests a dimension that's somewhere between a line and a plane.
So instead of having neat and tidy dimensions, we might be talking about a universe that exists somewhere in between dimensions, a universe with fractional dimensions.
Exactly. It challenges how we understand space and suggests that the universe is way more complex and intricate than we ever imagined.
I'm starting to feel like I'm going down a rabbit hole of infinite dimensions.
The journey's just beginning.
Okay, maybe we need to ground this a little before we get completely lost in the mass. Can we connect this to something more concrete, something we can relate to in our everyday lives?
Absolutely. Think about the branches of a tree. Each branch splits into smaller branches, and those split into even smaller ones. It creates this complex, self-similar structure, right? If you tried to measure the total length of all those branches, you'd find that it depends on the scale of your measuring tool. The smaller your tool, the more detail you capture, and the longer the total length becomes.
So the dimension of the tree, in a way, depends on how you look at it. It's not a fixed number, but a reflection of its fractal nature.
Precisely. And the same could be true for the universe as a whole. If it is a fractal, its dimension might not be a simple number like 3, but a fractional value that reflects its infinite complexity.
Okay, I'm starting to get my head around this, even if it feels a bit strange. But how do scientists actually measure these fractional dimensions in something as vast and complex as the universe?
That's a tough one. But there are techniques like box counting that can help. Imagine covering the fractal object with boxes of different sizes and counting how many you need to completely enclose it. By looking at how this number changes as we make the boxes smaller, we can estimate the object's fractal dimension.
So it's like playing cosmic Tetris, trying to fit different sized blocks around the universe to figure out its shape.
It's a simplified way of looking at it, but yeah, you get the idea. It's about using mathematical tools to quantify the complexity of a fractal structure, even if that structure is the universe itself.
This is all incredibly fascinating, but a part of me wonders if this is all just a really cool mathematical idea. Is there any real evidence that these concepts apply to the actual universe?
That's a fair question, and it's where the fractal universe theory needs to prove itself. We don't have definitive proof yet, but there are some intriguing clues. For example, some analyses of the cosmic microwave background radiation, that faint afterglow of the Big Bang, suggest fluctuations that align with a fractal distribution of matter and energy in the early universe.
So we're looking for traces of fractal patterns in the oldest light in the universe. That's amazing.
Yeah. And these fluctuations would have acted like seeds.
Seeds for what?
Causing some regions of space to expand faster than others.
Okay.
Eventually leading to the formation of galaxies and the large-scale structure we observe today.
So these tiny quantum hiccups created everything we see around us.
It's kind of poetic, isn't it?
It is, yeah.
Now, some physicists believe that these quantum fluctuations might not have just created our universe, but a multitude of universes.
So there could be more than one universe.
Imagine separate island universes, all expanding and evolving according to their own set of physical laws.
So our universe might just be one tiny bubble in a cosmic bubble bath.
It's a mind-bending possibility, right?
That is pretty wild.
And it ties in nicely with this idea of a fractal universe.
Yeah, how so?
Well, if the universe is fundamentally fractal, then this concept of a multiverse, this infinite repetition of patterns on different scales, becomes even more plausible.
Okay, my head officially hurts in the best way possible.
Now, mine too.
This whole conversation has been like a wild ride through a universe that seems both familiar and completely alien. We've talked about fractals, chaos, phase space, dimensions, and the idea that the universe might be infinitely complex and self-similar. My brain is definitely full. But I'm curious to explore the implications of all this. What does it mean for how we understand the universe and maybe even our place within it?
Now, that's a question that takes us beyond just science and into areas like philosophy and even spirituality. And it's a question that we'll explore in the final part of our deep dive. Stay tuned.
Welcome back to the Deep Dives. It's been quite the journey so far, exploring this mind-bending idea of a fractal universe, all these fractals and chaos theory.
Yeah, it really does make you think differently about, like, the whole nature of reality, you know?
Yeah.
Challenging how we think about size, scale, all that.
Exactly. We've covered a lot of ground, haven't we? The evidence for and against this fractal universe idea, the mathematical tools we use to study these complex systems, and this idea that even in chaos, there's this hidden order waiting to be discovered. But now I want to get to the big question. What does it all mean? Like, if the universe really is a fractal, what are the implications for us?
That's a big one, and it takes us beyond just science into, like, philosophy, spirituality, even art. If the universe is a fractal, it's like saying everything's connected on a level that's hard to even imagine. The patterns you see in the stars, they could be reflected in a leaf, the structure of our brains, even the way we think.
Wow, so it's like we're all woven into this giant cosmic tapestry, connected by the same basic principles. It's a beautiful thought. But it also raises some pretty mind-boggling questions, like if the universe is infinitely complex and self-similar, does that mean it goes on forever? Is it infinitely large?
That's a question that has puzzled scientists and philosophers for ages. I mean, mathematically, fractals can have infinite detail. But whether that translates to a universe that's actually infinitely large is still a debate. From what we understand about physics, the universe started with a finite size during the Big Bang. But the thing is, it's constantly expanding.
So maybe even if the universe isn't infinitely large right now, it could become infinite in the future. Like it's this fractal that's still unfolding, becoming more and more complex as it expands.
That's a fascinating thought. But even if it doesn't become infinitely large, the whole concept of fractals still challenges our ideas about scale and size. It's like saying there could be whole worlds hidden inside what we think of as empty space, just waiting to be discovered.
That's both exciting and kind of scary. It's like realizing the universe is full of secret passages and hidden dimensions that we're just starting to glimpse. But how does all this affect how we see ourselves in the universe? Does it make us feel more important or less important?
I think it depends on how you look at it. It's humbling to realize we're just a small part of this vast and intricate cosmos. But at the same time, it's empowering to think we're connected to everything in the universe. The same forces that shape galaxies also shape our lives.
So it's like we're both insignificant and infinitely significant at the same time. It's a paradox, but it's beautiful. I'm starting to see how this all fits together.
Me too.
But let's get to the really woo-woo stuff.
All right, let's do it.
We talked about galaxies and the universe.
Right.
But could consciousness itself be fractal in nature?
Now that's a big one.
I mean, is there any evidence for that, or is this just pure speculation?
Well, there's no definitive proof, of course.
Right.
But there are some tantalizing hints.
Like what?
Well, for example, the philosopher Carrie Welch has proposed that our consciousness might be like a temporal fractal.
A temporal fract.
Constantly shifting and evolving at different scales of time.
So that means?
We're taking in information, processing emotions, accessing memories, all happening simultaneously.
Huh?
It's like zooming in on a fractal and discovering new layers of complexity with each level.
It's like those moments when a single scent or sound can trigger a flood of memories.
Yes.
And emotions.
Exactly.
Transporting you back to a specific time and place.
Yeah.
Like accessing a whole world of experience through a single point in the fractal structure of your memory.
Precisely.
And what's even more intriguing,
What's that?
studies have shown that the brain's electrical activity exhibits fractal patterns.
That's right.
Whoa, hold on a second. Are we saying there might be a connection between the structure of the universe,
It's possible.
the way our brains work,
Yeah.
and our very experience of consciousness?
It's a lot to take in, isn't it?
That's some next-level stuff.
It is.
And it leads us to some even wilder theories.
Oh, yeah.
But we will save those.
For the next part of our deep dive,
Stay tuned.
Welcome back to our deep dive into the fractal universe.
We left off talking about the possibility of consciousness being fractal. Now, I'm no neuroscientist, but I'm having trouble wrapping my head around what that actually means for us as humans.
Yeah.
Does it change how we think about free will
Right.
or the sense of self?
Those are really great questions. And honestly, we're still in the very early stages of exploring these ideas.
Right.
But one way to think about it
Okay.
is through the lens of interconnectedness.
Interconnectedness.
If our consciousness is indeed fractal,
Yeah.
it suggests that we're not these isolated individuals,
Okay.
but rather nodes in this vast interconnected network.
So it's like we're all connected, not just through social media and the internet, but on a much deeper level,
Yes.
through the very fabric of consciousness itself.
Exactly. And this idea is actually supported by quantum mechanics,
Quantum mechanics.
which has shown that particles can be entangled,
Entangle.
meaning their fates are intertwined even when they're separated by these vast distances. Some physicists believe that this entanglement might extend to consciousness as well, suggesting a kind of cosmic web of interconnected minds.
Whoa, okay, that's pretty mind-blowing.
It is.
But let's bring this back down to Earth for a moment here.
Okay.
We talked about how fractal patterns show up in nature.
Right.
But what about in human society? Could this idea of fractality help us understand how our societies and cultures evolve?
Absolutely. Think about the structure of a city.
A city. Okay.
You have neighborhoods
Yeah.
within districts,
Okay.
districts within cities, cities within countries, and so on.
Right.
It's a hierarchical structure
Yeah.
that mirrors these fractal patterns we see in nature.
Right. And even within a single neighborhood,
Yes.
you have families, social groups, organizations, all these interconnected networks,
Exactly.
all interacting at different scales.
Precisely. And this fractal structure
Yeah.
isn't just limited to physical space.
So where else does it show up?
It also applies to the flow of information and ideas.
Information, okay.
Think about the internet.
Okay, the internet.
It's this vast network of interconnected nodes constantly exchanging information
Yeah.
and creating new connections.
And social media.
Yes.
It's like a fractal explosion of opinions, memes, and viral trends, all spreading and evolving at lightning speed.
That's a great example.
Yeah.
And it highlights the power of these fractal networks
Yeah.
to amplify and disseminate information.
Right? Okay, I think we need to take a deep breath
Yeah,
and process all of this.
for sure.
This concept of fractality is starting to feel like a key
Okay.
that unlocks this whole new level of understanding about the universe, consciousness, and even the way we organize ourselves as a species.
I agree. It's a truly powerful idea that can shed light on everything from the tiniest particles to the vast expanse of the cosmos.
But you know what else I'm realizing?
What's that?
This idea of a fractal universe doesn't just apply to the big stuff,
Okay.
like galaxies and consciousness. It's also reflected in the way we experience time.
That's a fascinating observation.
Yeah.
How so?
Well, think about it.
Okay.
We often perceive time as linear.
Right. Past, present, future.
But what if time itself has a fractal dimension?
Okay.
What if the past, present, and future are all intertwined and interconnected, just like those repeating patterns we see in a fractal?
That's a very intriguing idea.
Yeah.
And there's actually some scientific evidence to support it.
Oh, really? Like what?
For example, in quantum physics,
Okay.
the concept of retrocausality
Retrocausality.
suggests that future events can influence the past.
Hold on. Are you saying time travel might actually be possible?
It's not quite that simple, but the
Right.
idea is that time
Yeah.
might not be as straightforward as we think.
Right.
And if time has a fractal dimension,
Right.
it could mean that our past, present, and future are all influencing each other
Whoa.
in ways we can't even begin to imagine.
Okay, my mind is officially blown.
I know, it's a lot.
So if time is fractal,
Yeah.
what does that mean for our understanding of free will? Are we really making choices?
Right.
Or are our actions predetermined
Yeah.
by this complex web of interconnected events?
Again, these are deep philosophical questions that
Yeah.
we're only beginning to grapple with.
Right.
But this idea of a fractal universe suggests that our choices might be both free and determined at the same time.
Both. How is that possible?
It's like we're navigating a landscape
Right.
with infinite possibilities,
Right.
but our path is also shaped by the underlying structure of that landscape.
So it's like we're writing our own stories, but within a larger narrative that's already in motion.
That's a beautiful way to put it.
Yeah.
And it highlights the importance of both individual agency and this interconnectedness of all things.
Okay, I need a moment to process all of this.
Take your time.
But before we get too lost in the metaphysical weeds here,
Yeah.
I'm curious to hear more about the practical implications of this fractal worldview.
Right.
If everything is truly interconnected,
Mm-hmm.
does that change how we should live our lives?
That's a great question, and it's something we'll explore further in the final part of our deep dive.
Okay, can't wait. Welcome back to the final part of our deep dive into the fractal universe.
We've covered a lot of ground,
We have.
from the structure of galaxies to the nature of consciousness.
Yeah.
It seems like this concept of fractality touches on every aspect of existence.
It's definitely been a mind-expanding journey.
For sure.
But before we wrap up,
Yeah.
I want to circle back to that question we posed earlier.
Okay.
If everything is truly interconnected, what does that mean for how we should live our lives?
That's a question that philosophers and spiritual teachers have grappled with for centuries.
Yeah.
But this idea of a fractal universe adds a whole new dimension to it.
Okay.
If the universe is indeed a reflection of itself at every scale,
Yeah.
then our individual actions have a ripple effect that extends far beyond what we can see or even imagine.
So it's like the butterfly effect, but on a cosmic scale.
Exactly. Every choice we make,
Mm-hmm.
every action we take,
Yeah.
creates a vibration that reverberates throughout this interconnected web of existence.
Okay. That's both daunting and empowering, isn't it?
It is.
It means we have a responsibility to be mindful of our thoughts and actions because they can literally impact the world around us.
I think it's more about recognizing our interconnectedness than feeling burdened by responsibility.
Right.
It's about understanding that we're not separate from the world, but rather an integral part of it.
Yeah.
When we act with kindness,
Okay.
compassion, and understanding. Yeah.
We're not just helping others.
Right.
We're contributing to the overall harmony of the universe.
So it's not just about, like, doing good deeds. It's about cultivating a certain way of being in the world.
Precisely. It's
Yeah.
about recognizing the interconnectedness of all things
Yeah.
and living in alignment with that understanding.
And recognizing the inherent beauty
Yes.
and sacredness in every aspect of creation.
Absolutely.
You know, that reminds me of something we touched on earlier.
What's that?
The idea of a global human evolving through history.
Right.
If we take that idea seriously,
Yeah.
then our individual journeys of growth and transformation become even more meaningful.
Yeah.
It's like we're all contributing to the evolution of consciousness itself.
I love that perspective.
Yeah.
It reframes our lives as something much grander
Yeah.
than just our individual experiences. We're all part of this larger story, a cosmic narrative that's unfolding over eons.
And that narrative seems to be moving towards
What? Greater complexity, interconnectedness, and consciousness.
Yeah.
It's like the universe is constantly striving to understand itself, and we're all playing a role in that journey.
I think that's a beautiful way to sum it up.
Yeah.
We're all part of a grand cosmic adventure.
And it's up to each of us to make the most of it.
To live our lives with purpose,
Right.
passion, and a deep appreciation for the interconnectedness of all things.
Well, dear listeners, that brings us to the end of our deep dive into the fractal universe.
Sad to see it end.
I hope you've enjoyed exploring these mind-blowing concepts with us.
It's been a privilege to share this journey with you.
We encourage you to continue exploring these ideas on your own.
Absolutely.
Look for the fractal patterns in nature, in your own life, and in the world around you.
That's right.
Embrace the interconnectedness of all things, and remember that even small actions can have a ripple effect that extends far beyond what we can see.
And as always, keep asking questions, keep seeking knowledge, and keep diving deep into the mysteries of the universe.
Until next time, fellow explorers.